Hi, I'm Atul and I am in London right now.
Hi, I'm Paul and I'm in Burnley, Lancashire right now. Okay, so we're going to look at the calculation for the pH of water. And for calculating the pH of water, we use the ionic product of water. And that equation is Kw equals our aqueous hydrogen ions and our aqueous hydroxide ions. And so if we rearrange this for H plus, Kw over our hydroxide ions, and therefore Kw were given in the question. And we're not given hydroxide ions. So you'll notice we don't have enough information for this in the question. We're not given hydroxide ions. So we're going to have to think of something else to do here. And what we know with water, what do we know about hydrogen ions and hydroxide ions in water?
Well, yeah, for water they have to be the same amount for perfect neutralization, yeah, so they have to be the same.
So what we can do with water is say if H plus and OH minus ions are equal, we can change this equation to Kw equals H plus squared, and therefore if we square root both sides, we get H plus will be equal to the square root of W, and therefore will be equal to the square root of 5.48 times 10 to the minus 14. And could you try that in your calculator?
Yeah, just doing that now. My trusty Casio. Getting 2.34 times 10 to the minus 7.
So now we've got the hydrogen ion concentration, we can just minus log the answer, because pH is minus the log of H plus, and that should give us the pH of our water. So to 2 decimal places, what would that come out as?
I'm just doing a minus log of the answer, quite literally, just there.
Excellent.
It gives me 6.631, or let's call that 6.63.
6.6. We give pHs to 2 decimal places.
Right.
6.63 is the pH of our water. Now, question B says, is the water neutral? Explain your answer. So why might some students think this water isn't neutral?
Well, I think we have always been told that pH 7 is what's neutral, so this seems to be very slightly towards the acidic end of the scale.
Yeah, but it's water, so we must know it's neutral, and all that pH 7 refers to is the neutrality of water at 25 degrees C, under standard conditions. And here we're not under standard conditions, we're at 50 degrees C. So water at different temperatures because you get different dissociation of water at different temperatures, you can get different pHs. And so, is the water neutral? Yes. Explain your answer. Is because the hydroxide ions still equal the hydrogen ions.
Of course, yeah, that's what I was also curious about, is because the moment we stopped and he asked me what's the assumption in neutrality, well, hydroxide ions number is the same as the hydrogen ions, so implicit in that statement is neutrality already. You wouldn't be able to do anything unless you assumed it was neutral.
Exactly. We can only do this calculation because it is neutral. And our H plus, because our H plus equals our OH minus.
Right. No, I think it's a great question of just going beyond that sort of fixed idea of pH being 7, because until now, I suppose, until A levels, it's almost like gospel, isn't it? It's like pH 7 is
that's all you've been taught all the way through school, almost up to now.
Thanks to some advertising by shampoo companies and soaps as well, it's like pH 7 is even more regarded as a neutral. But of course, it's only as with many things in chemistry, it's at certain conditions, physical conditions, temperature, pressure, etc. So it's a good sort of snapping out of that kind of mode question. Yeah. Great, sounds good. I'll look forward to any other pH questions.
Okay, thanks, Atul.
All right, bye for now.
Okay, bye.